Next, we're going to look at the opposite way of using the normal distribution, and that is, given a probability, like say 10%, we want to find the x value. And once again, there are two functions for that. We can use norm.inv, in which we will provide both the mean, mu, and standard deviation sigma, so you will get the x value out. Whereas if you use norm.s.inv, you'll get the z value, like how you would use the normal distribution table. And then once you have the z value, then you have to calculate the x value yourself by using a formula like that. For both norm.inv and norm.s.inv, what we have to provide is a cumulative probability. So you have to make sure that whatever the probability that you want is first converted into a cumulative probability. So here the given probability is what is the least dollar amount of the top 10%. So given probability of 10% is the tail probability, the top 10%. So you have to first convert that into cumulative probability, which is 1 minus that. So that is the cumulative probability. Then we can use norm.inv. Okay, start with the cumulative probability, comma, mean, comma, standard deviation. So that will give us the x value directly for the top 10%. If you wanted to use norm.s.inv, then remember that will only give you, okay, again you have to provide the cumulative probability, and that will give us the value of z. Okay, then we have to compute the x by going mu plus z sigma. So do that, we get the same answer, of course, but you have to do that extra step. The next problem is slightly more complicated. Here we want the middle 95% of customer charges. So if you look at the graph here, this is like that middle part is 95%, and we want these two x values, the lower limit and the upper limit. So we have to first find the cumulative probability for these 2 points. So if this middle area is 95%, okay, so we'll call that 1 minus alpha. So the two tails put together then is 1 minus that middle area. So this is our alpha. So we take half of that, because that will be half of that would be one tail, and then the other tail. So that is now the cumulative probability for the left side tail. So left side tail, the cumulative probability is just alpha over 2, and the cumulative probability here is 1 minus alpha over 2. So this is 1 minus alpha over 2 is the cumulative probability for the second point. So now that we have the two cumulative probabilities, then we can apply those cumulative probabilities to norm.inv, cumulative probability of the left point, comma, the mean mu, comma, standard deviation sigma. So that will give us the left point. Do the same thing for the right side tail, cumulative probability, mean mu, standard deviation sigma. So that will give us the two x values for middle 95%. Now of course we can do the same thing using the norm.s.inv, in which case you will first find the z and then use that z in a formula like that to get the same two x values. So I'll show the final answer. So we have norm.s.inv of E63 that gives us the first z value for the left tail, and then E64 z value of the right tail, and then mean mu plus z times sigma for the left, and then mean mu plus z value for the right tail times sigma gives you the same answer like in the previous case.